This is just a quick reminder that you should feel free to pause the video if you ever feel you want more time to think and write. Welcome to section 5.21. This is exponential functions and graphs. And you can see here, what I'd like to do is actually start off with a little bit of a review. I've got this table, and I'd like you to fill it out as we go. You take 2 to the 4th. Let's say the exponent is 4. 2 to the 4th is 16. That means 2 times 2 times 2 times 2 is 16. Great. And then you also notice that 2 to the 3rd is 8, and 2 squared is 4. What's the pattern as you read the table from right to left? If you go backwards, really what you want to do is to go from 16 to 8 to 4 is you divide by 2 each time. Divide by 2, divide by 2. And the pattern holds. You can see here 2 to the first power is just going to be 2. And so, and the pattern holds 4 divided by 2 is 2. And that's one of the reasons why we can say 2 to the 0 is going to be 1. It's because we take 4, and to get the next one we divide by 2, and take 2 and divide by the next one to get 1. If you want to figure out what the next lower exponent would be in the 2 to the x function, like if this is 2 squared and 2 to the first and 2 to the 0, you want to figure out what the next one is, well then you have to follow the pattern. Divide by 2. So 1 divided by 2 is actually 1/2. Right here, 1 divided by 2 is 1/2. So that's how we can kind of reason that 2 to the negative first power really is 1/2. Then you keep on going, you can say you divide that by 2, and you get 1/4. 1/2 cut in half is 1/4, and that's the same thing as 2 to the negative 2. And then cut that in half again, and you get 1/8. That's the same thing as 2 to the negative 3. Cut that again in half, you get 1/16. And that means 2 to the negative 4 is 1/16. What I really want to remind us is something that we've seen before and someone else has taught you before, but it's always a good reminder that negative exponents are related to fractions. If you think to yourself, wait a minute, what am I supposed to do with this negative exponent? Chances are the answer is going to be, well, change it into some sort of a fraction. And sometimes this fraction is going to be a lot easier to deal with than the negative exponents. So the next big question, now that we have a little bit of review under our belts, I want to ask one really big question. What happens when you put a variable in the exponent? So we've seen x squared before, but that's not what this is. This is 2 to the x. 2 to the x. Well, what we've got here is a table. 2 to the second power is 4. 2 to the first power is 2. 2 to the 0 power is 1. And as we saw in the table before, 2 to the negative 1 is 1/2. 2 to the negative 2 is 1/4. If you graph these, you get something that starts doubling very quickly. Every one, if you go to the right, you double your value. Go to the right one and double. Go to the right one and multiply by 2. You go from 1 to 2 to 4 to 8. It gets very steep very quickly. Same thing down here. If it's to the 0, then you go left and cut it in half. Go left, cut in half. Go left and divide by 2. This is what we call an exponential function. Let's do the same thing again with 3 to the x. This is 3 squared. If you haven't noticed already, I really enjoy filling out these tables, not from top to bottom, but from bottom to top, so that we save the negatives for last once we see the pattern. 3 squared is 9. 3 to the first is 3. 3 to the 0 is 1. 3 to the negative 1 is the fraction, 1/3. 3 to the negative 2 is the fraction 1 over 3 squared, which is 9. And if you plot these points, you get something like this. You can see the y value is triple every time. You go to the right one and multiply by 3, to the right one and multiply by 3, or cut into thirds, or cut into thirds. Now what happens if you have a fraction? 2, let's see, if 2 is the input, then that means you want 2 to be the exponent. 1/2 squared is 1/4. 1/2 to the 1 is 1/2. 1/2 to the 0, just like anything else, is going to be 1. Anything to the 0 is 1, just as long as it's a positive number. 1 half to the negative 1 is 2. And so you might wonder how that came about. Well, one answer is that if you want to go like this, you have to double it. Double, double, double. Another answer would be to say directly that if it's to the negative 1, then that would be 1 over 1 half, which is equal to 2. Another way to say it would be if you take this negative 1 and distribute it to the 2, then you get 1 over 2 to the negative 1, so the 2 comes up to the numerator, and you get 2. Anyway, 1 half to the negative 2 would be 4, for all the same reasons. If you plot all those points, you get something like this. 8, 4, 2, 1, 1 half, 1 fourth, 1 eighth, 1 16th. And how do these compare? How does this compare to this compare? Well, it's a horizontal reflection. You can see all the points started over here and they get reflected over. All these points started over here on the left and they got reflected over to create this graph. It's a horizontal reflection. Anyway, you can say that an exponential function is of this format, a to the x, where x is a real number and a is greater than 0. We don't want to deal with what if a is negative. That's going to be too complex. And if a is not equal to 1, it's an exponential function of base a. Now might be a good time for me to tell you that sodium is one of my favorite elements of all time because it goes on top of soft pretzels. Yum. Connecting the concepts, properties of exponential functions, this is what they look like. They are of this format. Just so long as a is a positive number, and if it's a is not equal to 1, then we know this. First of all, the function is continuous. That means you can draw it. It doesn't have any breaks in the graph. You can draw it without lifting up your pencil. It's going to be what we call 1-to-1. That means in these three cases, it's always increasing. And in these cases, they're always decreasing. The domain is going to be negative infinity to infinity, so you can see all x values. You can take any x value you want and put it into the exponent. The range is going to be from 0 to infinity. They can go as high as you want, and they can get down as low as you want to the x-axis, but they will never cross the x-axis. And it's increasing if a is greater than 1, like 2.5, 4, 1.8. If a is greater than 1, this is what you get, and if a is less than 1, then you, like this, 0.7, 0.4, 0.25, then it's going to look like that. Actually, this is an error. This should be a 1. It'll have a horizontal asymptote of y equals 0. That's the x-axis. And it'll always have a y-intercept of 0, 1. Notice all of these go through the same point right here, 0, 1. Let's take a look at the parent function y equals 2x. We've seen these values before. 2 to the x power, 4, 2, 1, 1 half, 1 fourth. Now, what if we transformed that? What if we took that as a parent function and we said we don't have just x anymore, we have x minus 2? What we'd see is we'd see all of these values shift plus 2. So, for example, this is what it would look like. They shift to the left 2 units, shift to the right 2 units. These points all become these points right here. This is the parent, and this is the transformation. Here, if we can see this is the original 2 to the x minus 4, it'll have a vertical shift of negative 4. You can plot the original and then just shift all the values down 4 units. Something a little bit more complex. We get f of x is equal to 5 minus 0.5 to the x, or 1 half to the x. And just to make things a little easier to read, I'm going to move this 5 over to the other side. We get negative 0.5x. And just to change it to a fraction, 0.5 becomes 1 half to the x. And then on top of that, you can say that 2 to the negative 1 is the same thing as 1 half. And then I'm going to take these exponents and combine them, just multiplying them together. You get negative 1 times x is negative x plus 5. If the original is f of x, if the original parent function is 2 to the x, then we've got three things going on here. We've got a vertical shift of 5, a vertical reflection right here, because there's a negative 1 out in front, and then a horizontal reflection here, because it's a negative x. So those three transformations are what it looks like. I'd like you to start assignment 5B1. That means copy the assignment list and then do the first problem. And I'll see you in class.